Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to discuss the chapter Redox reaction. Okay, this is very important chapter to understand electrochemistry in your PU2, right? So that is why you should know what is oxidation reduction. So this lecture is very important and it is a small topic. Weightage wise also it is very low, but yes, the basics of it are very essential for the PU2 chapters. Okay, so let's get started. So today we are going to discuss what is the redox reaction types and what is oxidation number. Okay, so I'll be telling in part 1, that is in today's lecture we are going to discuss these things. Okay, so that is classical idea of redox reaction, then redox reaction in terms of electron transfer, oxidation number and types of redox reaction. Okay, and next in part 2 we'll get disproportionation reaction, balancing redox reaction and titration. Okay, then we'll be discussing redox reaction and electrode processes. Fine. Now year wise weightage, if you see, it is like one question you can expect every year. Okay, fine. Next, today's lecture, these are the things that we are going to complete. Okay, so first let us understand what is the classical idea of redoxation reaction. Okay, so classical idea means old method. So in old method, oxidation means addition of oxygen or any electronegative element. Okay, if you are adding oxygen to, suppose there is one element X. Okay, so if you are adding oxygen or any electronegative element to this element, okay, then this substance is said to be oxidized. Similarly, if you are removing any hydrogen or a electropositive element from a substance, then also it is defined as oxidation. Okay, now for example, if I write Mg plus O2, okay, gives 2 MgO. Okay, 2 Mg plus O2 gives 2 MgO. This is nothing but oxidation reaction because you are adding oxygen to Mg, right? So we can say that magnesium is getting oxidized. Similarly, if you talk about reduction, removal of oxygen or electronegative element is called as reduction. Okay, now similarly addition of hydrogen or electropositive element is also called as reduction. Now for example, if you have N2 plus H2, okay, gives 2NH3. Okay, so now you can see here you are adding hydrogen to N2. Okay, so that will give you NH3. So this is called as reduction reaction. Okay, fine. Next, coming to redox reaction in terms of electron transfer. Okay, so oxidation is loss of electrons, reduction is gain of electrons. Okay, and what is oxidizing agent? So the substance which gets reduced during redox reaction is called as oxidizing agent. Now see, so we have a definition. So every element do not have oxygen, or there are certain like modified definitions of oxidation and reduction. So oxidation means loss of electrons and reduction means gain of electrons. Okay, now suppose there is a substance A. Okay, it has lost one electron. So what it will become? A plus and the lost electron. Suppose B has gained one electron. Okay, then we call it B minus, right? So this is what oxidation and this is reduction. Okay, now there is the substance which gets oxidized, okay, is called as a reducing agent. The substance, this is very important, you should remember, the substance which gets oxidized is called as a reducing agent, and the substance which gets reduced, okay, this B is getting reduced and that is called as the substance which gets reduced is called as oxidizing agent. Oxidizing agent. Clear? So the substance which gets oxidized is called as reducing agent and the substance which gets reduced is called as oxidizing agent. Okay, next, coming to redox reactions in terms of electron transfer. So when in the same reaction one element loses electron and the other gains electron, it is called a disproportionation reaction. Okay, so now you see, suppose you see zinc and when in the same reaction one element loses electron and the other element gains electron, so this is called as your redox reaction. Okay, small definition error is here. Now see, if you see zinc, Okay, now from Zn to Zn2 plus, how does this has occurred? Zn has lost 2 electron, right? So Zn is undergoing oxidation. Okay, now if you see copper 2 plus to copper, okay, so copper will gain 2 electron to become copper. So here copper is undergoing reduction. Okay, so when in the same reaction you have one oxidation and one reduction, that is nothing but redox reaction. Okay, fine. Now let us talk about what is oxidation number. So apparent charge possessed by an atom in a molecule. So what is the charge of one atom in a particular molecule? That is called as oxidation number. Okay, so now oxidation number of an element in pure form is always 0. Like for example, oxidation of O2, H2 are 0 because they are in the pure form. Next, oxidation number of atom in the monoatomic ion is equal to the valence to the charge of the ion. Like for example, if you say sodium, okay, the sodium is a monoatomic ion, its charge, its valency is +1, so its oxidation number is also +1. So here are some rules that you should know to calculate the oxidation number. For example, oxidation number fluorine, chlorine, bromine, iodine is always -1. Oxidation of group 1 elements are +1. Oxidation number of alkali earth metals means group 2 elements is always +2. Oxidation number of oxygen is -2, but in peroxide it is -1 and in superoxide it is -1/2. Similarly, oxidation number of hydrogen is +1 and for metal hydrides it is -1. Okay. Now let us take a small example and solve a question from here. Okay. Suppose I'll give you calculate the oxidation state of, I'll write one element like this. Okay. Calculate the oxidation state of manganese. How to calculate? Potassium. Potassium is a group 1 element, right? Group 1 element will have +1. So oxidation state of potassium is +1. Okay. Manganese I want to find out, I don't know, let it be X. Okay. Next, oxygen oxidation number is -2, right? So but there are 4 oxygens, so it is 4 into -2 equal to 0, right? So now if I calculate, this is +1 plus X minus 8 is equal to 0. So X is equal to +7. Right? So manganese oxidation state is +7. Clear? Now let us do one more question like this. For example, if I take Fe2O3, or let me take this one, Fe2O3. You want to calculate the oxidation state of iron. Okay, so we want to calculate oxidation state of iron. We don't know, let it be X. Now there are 2 iron, so it will be 2X, right? Now oxygen I told you is -2. There are 3 oxygen, so it is -6, and the net charge will be equal to 0. So if I calculate, X will be +3 here, right? Now for example, you calculate for, there is an iron SO4 2-. Okay, calculate the oxidation number of sulfur. Okay, so let it be X plus oxygen is -2, there are 4, so -8. Okay, now here you should not put 0. Now here I was equating it to 0, but here you see the total charge is -2, so it will become -2. So X will be equal to +6. Okay, clear? Okay. Next, how to determine oxidation and reduction based on oxidation number. Okay, so the oxidation is like oxidation number, when it increases it is oxidation, and when the oxidation number decreases it is reduction. Okay, so like for example, the example that we saw, Zn plus Cu2 plus is giving you Zn2 plus Cu. Now see, Zn oxidation number is 0. Zn2 plus oxidation number is 2 plus. So from here to here what is undergoing? Oxidation, because the oxidation number increases from 0 to +2, right? Now if you see from here to here, Cu +2 to 0, right? So copper is undergoing reduction. Copper is undergoing reduction, right? So +2 to 0. Clear? The oxidation number here is +2 and the oxidation number here is 0. So +2 to 0, what will happen? The oxidation number is decreasing, that is why it is reduction. Okay. Next, coming to types of redox reaction. So it is very similar to your types of chemical reactions. The first one you must remember is combination. So combination reaction is where elements combine to form the products. So you can see Mg and O2 is combining to give you MgO2. Mg plus N2 is combining to give you Mg3N2. Okay, so this is combination. Next, decomposition reaction. A compound decomposes to form products and at least one of the product must be an element. So if you see, water decomposes to give you H2 and O2. This is an example of decomposition reaction. Okay. Next, this is important. Displacement reaction is very, very important. An atom or ion is displaced by another. Okay. So in this we have again two category. One is metal displaces another metal. Okay. One metal is displacing another metal. A metal is displaced by a metal or another non-metal. So we will see one example where zinc and copper sulfate is reacting. Then what will happen? Zinc is a higher reactive metal, so it can replace copper and we get zinc sulfate plus copper. Okay. Similarly, if you have Cr2O3 plus aluminium, okay, Cr2O3 plus aluminium, then what will happen? Aluminium can replace chromium, right? Aluminium can replace chromium and we get Al2O3 plus Cr. Clear? Similarly, there is one more chance, that is non-metal. Okay, non-metal is displaced by another non-metal or metal. Okay, so a non-metal is displaced by a metal or another non-metal. So you can see here, suppose hydrogen, okay, is a non-metal. It is displaced in this reaction by a metal. Hydrogen, if you react with sodium, what will happen? You will get NaOH plus H2. So what is happening here? This H2 is replaced by Na, right? So metal is displacing this non-metal. There is another way where the non-metal displaces the non-metal, that is a halogen displacement reactions. So you should remember that fluorine is the strongest oxidizing power. That means fluorine can replace chlorine, bromine, iodine. Chlorine can replace only bromine and bromine can replace only iodine. Iodine cannot replace anything. So you can see, if I react F2 and KCl, right? So fluorine can replace chlorine and we will get KF and Cl2. Similarly, if chlorine reacts with bromine, so what will happen? Cl will replace bromine and Br2 will form. Next, F2 is reacting with water. Here also remember, F2 can even displace oxygen, okay, because it is the strongest oxidizing agent. So what will happen here? HF will form and O2 will be excluded or will be produced as a byproduct. Okay, so the strongest oxidizing power is of fluorine. It can displace chlorine, bromine, iodine and even oxygen. Okay, now we'll do some questions. So here was a question that I gave you from the equilibrium chapter, last one homework question. What is the pH of a solution obtained by mixing 10 ml of 0.1 m HCl and 40 ml of 0.2 m H2SO4? So here I also given you hint to calculate the number of moles first, right? So if you remember, number of moles is equal to molarity into volume, right? Molarity, okay, into volume. Now if I see, what is the molarity here? 0.1 m, okay, and we have 10 ml, so that is 1 millimoles. Okay. Next, coming to number of moles of H plus from H2SO4. Okay, so we will have 0.2 m into 40 ml into 2. Okay, so we get 80, 42 is 80, 80 into 0.2 is 160, so 16 millimoles. Okay, 42 is 82 is 160, 16 millimoles, right? So total number of n moles of H plus is how much? NH plus total is equal to what? 17 millimoles. Okay, and what is the total volume? Total volume will be 40 plus 10, 50 ml. Okay, so I'll get 17 by 50 is the concentration of H plus. Okay, clear? So now 17 and 50, if I divide, we will be getting like 17 divided by 50, right? Let me solve it. So I can say 53 is a 150. Okay, then I'll have 20. Then I can say 54 is a, right? So 0.34. Okay, now if I want to calculate the pH value, okay, so let me solve this one. So I'll arrange this one. What is the pH value? pH is minus log of 3.4 into 10 to the power of minus 1, right? I can write it like this. So it is minus log 3.4 minus 1, right? So if I see now, log 3 value is 0.6, right? 0.6 is log, no sorry, 0.477 is log 3 value, right? So 0.477, I'm just taking log value and minus 1, okay? So this is log 3 value, I'm just doing an approximate calculation. So 1.000 minus 0.477, so it will be 10 minus 7, 3, 9 minus 2, 7 minus 2, 4, 0.5, 0.523 I'll get, right? It will be little lesser than that, so that we will get plus 0.523, okay? But you can see the answer should be nearer to 0.523, okay? So I think the answer has to be option number D, that is, which is nearer to 0.52, option number D. Okay, now let us go to the next question. When zinc is kept in a copper nitrate solution, what happens? So this is from the displacement reaction. Zinc is there, okay, and you have copper nitrate solution, right? So you know zinc can displace copper from the solution, so zinc nitrate solution will form, okay? So zinc is deposited on copper, no. Copper is deposited on the zinc, so zinc nitrate will form and copper will form precipitate and will get deposited on the rod itself, okay? So that is option number B is correct here. Next, question number 2, in this reaction copper 2 plus zinc gives you copper plus for Zn2 plus, what is an oxidizing agent? So if you remember, for oxidizing agent is the one which is undergoing reduction, right? So copper 2 plus is undergoing reduction here, so copper is the oxidizing agent. Next, loss of electron is, this is very important question, loss of electrons is oxidation, gain of electrons is reduction. Next, which of the following is true as per the metal activity series? So if you remember, I want to tell you zinc is the most reactive, then copper and then silver, okay? So the correct answer is option number D here. Next, intensity of blue color increases gradually when copper rod is dipped in a silver nitrate solution, silver rod is dipped in a copper nitrate solution, zinc rod is dipped in silver solution, copper rod is dipped in zinc rod solution. So for this you should know the order, that is zinc, copper and silver, right? So we will get, sorry, not this question, yeah, we have zinc, copper and silver, right? So now we want blue color, okay? So any solution of copper should be forming, okay? So any solution of copper should be forming, okay? Then that will give you blue color solution. Now if zinc is displacing copper, then copper will get deposited and a solution of zinc will form. But if copper is displacing silver, okay, suppose there is Ag sulfate or Ag nitrate, copper will displace silver to give you copper nitrate, which is a blue color solution, right? So what does that mean? Copper should be dipped in silver solution. So you can see copper is dipped in silver nitrate solution. If I put this one, this is copper and this is silver nitrate solution, right? So in that case what will happen? Copper will displace silver and we will get copper nitrate solution, and this copper nitrate solution is blue in color, okay, clear. Next, question number 6, in the reaction of formation of magnesium oxide, magnesium undergoes formation of magnesium oxide. So we have magnesium plus oxygen, that gives you magnesium oxide, okay? So now this magnesium oxygen is added to this one, so it is undergoing what? Oxidation, okay? Next, question number 7, SnCl2 plus 2 FeCl2 gives SnCl4 plus FeCl2, okay, sorry, this is FeCl3, is an example of. So if you now see, let us calculate the oxidation number. I told you chlorine oxidation number is -1, right? So what will be in SnCl2, okay, this is X plus this is -2, this is equal to 0. So X will be equal to +2, right? We will get +2 here. Next, if you see FeCl2, sorry, this is FeCl3 and this is FeCl2. Okay, one second. So if you see, here it is plus 3. Similarly, here it will be plus 4 and here it is plus 2. So plus 2 to plus 4 oxidation number is increasing. So Sn is undergoing oxidation. Plus 3 to plus 2 oxidation number is decreasing. So iron is undergoing reduction, right? So it is a redox reaction. Option number C is the correct answer here. Next, this is a homework question. What is the oxidation half of this reaction? You have to identify it. Okay. So yes, students, that's all in this class, and I hope you have understood the basics of redox reaction and all. Tomorrow's class we are going to do very important thing, that is about balancing of reactions and disproportionation reaction. Okay. So please subscribe the channel and just make sure that you are watching all these videos, because this will help you to get very good marks in your KCET examination. So please students, prepare like seriously for your examinations from now onwards. Thank you once again, and do not forget to subscribe the channel.